Okay, we're going to talk about heats in chemical reactions. And when you write it up, the amount of heat that's produced or the amount of heat that's required, okay, that's the heat of reaction. So when I say what's the heat of reaction for the formation of hydrogen chloride from hydrogen gas and chlorine gas, you'd say it's 185 kilojoules. And as we mentioned before a little bit, we worked on some calculations with it. When it's your product, you're releasing heat. It's an exothermic reaction. In this case, it's on the reactant side. So that means I need to put in heat to get this reaction to go. And when you require heat, it's an endothermic reaction. Okay? And we can use it just as we've been using the mole-to-mole ratios. These amounts, again, can be used also as part of your conversion factor. So, on the second one here, I say how much heat is required when completely reacting two moles of N2. Then as we did in the past, we do this again. We would set it up and we say, okay, so I know I'm starting off with 2 moles of nitrogen, and the relationship is that for every 1 mole, because that's my coefficient here, of nitrogen, it requires 181 kilojoules. So once I do that, then I can 216 put a 1, 362 kilojoules required. Okay, so you use that as part of your conversion factor instead of just everything mole to mole. Now you're doing mole to kilojoules. What's also important for you to be able to interpret, because we use this a lot, is a relative energy diagram. Okay, so what happens is this. Right here, let's call this energy. And as we go left to right, this is reactants to products. Okay, anytime you go to the right, you're going to be looking at products. So if we look at our first reaction that I had written, hydrogen plus chlorine goes to hydrogen chloride plus 185 kilojoules. Okay, so it's releasing energy. So on the products, what I've done here, I start with my reactants. Remember, I'm releasing it, so here would be my products. And if I look, this difference in energy from here to here, that difference is 185 kilojoules. So when I'm releasing heat, it's like I'm rolling down the hill. what happens if I look at an endothermic reaction? So my products will be lower than my reactants in an exothermic reaction. What happens if it's endothermic? Well, if it's endothermic, then let's take a look at the one we had. Let's do this one. 6 carbon dioxide plus 6 waters plus 2,519 kilojoules gives me glucose plus 6 oxygens. Okay, so here my reactants are carbon dioxide and water, and my products right here, glucose and oxygen. And what happens is this: if we look at this reaction, then the difference between these two lines right here and right here, and going uphill now, I need to add in the 2,519 kilojoules. This is endothermic. So whenever you see that my products are higher in energy than my reactants, then I have to put in energy to roll all my reactants uphill, and that's why it's going to require energy, and it's endothermic. I need to put heat in there to make it go. Okay, and that's actually what plants do, because they're absorbing sunlight, and it's the energy from sunlight that they're using to do this reaction. So they're actually putting energy in, the 2,519 kilojoules. They're absorbing that through sunlight in order to get this reaction done.